Okay, you ready? All right, 1.6 part 2. These are inequalities. Now, we have two types of inequalities like we did when we were doing just regular compound inequalities. Yes. Okay, so who gets the U, the and or the or? The ors, right, are going to be unions. Okay? Okay, but you got to be a little careful here. The less than sign, the less than or less than or equal sign, are going to be our and problems. You're going to have to set these up. It's not like you have to figure out which ones are and or. Yes. Yes. Less than or equal to are for the and problem. The greater than or equals are going to be your ors. Okay? Unlike compound inequalities, they give you the and or ors, right? These you have to figure out which one's and which one's or. Okay, and then you just solve, and when you split them up, because these are inequalities, you obviously have the one that's positive, right? 2x plus 7 is less than 11. But then we have to do the negative side, right? So 2x plus 7, and then we have negative 11. But think about going from positive 11 to negative 11. We're actually multiplying by negative 1, right? So what do we have to do with the sign? You got to flip it. Okay? So the one that's there, this happens to be a positive 11, you keep the sign as is. Then when you do the opposite of what's there, you have to flip that sign. So you've got, right off the bat, you've got two new rules you have to follow. Okay? Less than signs are going to be ands, and when you set this up to the opposite of what's there, you have to flip the sign. Two brand new rules right off the bat. And then everything else stays the same as with compound inequality. Not yesterday. Yesterday we did equalities. We did compound inequalities last week. Remember, you took that quiz online? Some of you got the compound inequalities? All right. Let's. And again, don't forget the rule where you have to isolate the absolute values first. Then you determine whether it's an and or problem. Yeah, C, you can't just say, oh, that's an and problem. You can't do that. You have to isolate the absolute value first, then determine, because you may have to flip that sign. Okay, we'll do some examples, all right? I know we got a little bit ahead. We just got a little bit ahead. We'll go back. All right, so let's do our and problem. Because our absolute values are our absolute value term is isolated, we go ahead and determine that this is an and problem because it's less than. So 2x plus 7 is less than 11, and 2x plus 7 is greater than negative 11 because we have to flip the sign. Then we just go ahead and solve each inequality. So I'm going to subtract 7. If you want to do one problem at a time, by all means do it, because if I usually do them both at the same time, it's just habit. Okay. So I'm going to subtract 7. I get 2x is less than 4. Then I'm going to divide by 2, divide by 2. So I get x is less than 2, and, okay, subtract 7, I get 2x is greater than negative 18. Then I'm going to divide by 2. Do I have to flip the sign? No. X is going to be greater than negative 9. Now, does anybody remember what our and graphs are going to look like? Yeah, it's in between, right? So here's my smaller number is what? Negative 9 or 2? Negative 9, just pick one of these. And pick one of these, 2. Do I have a bracket or parenthesis at negative 9? Parenthesis. How about at 2? Shade in between. It's an and problem. Shade in between. If it's an or problem, shade outside. Bracket is with an equal sign. If this had an equal sign, you use the bracket. And the interval, I have parenthesis, negative 9, comma, 2, parenthesis. Not too bad. Just like compound inequalities, except you have to determine if it's an and or, right? And you have to flip that inequality sign. Okay, let's do the or problem. You're going to 3x, the absolute value of 3x minus 2 is greater than or equal to 8. My absolute value is isolated, so I go ahead and split it up. 3x minus 2 is greater than or equal to 8. It's exactly what's there. Or, it's an or problem because it's greater than or equal to 3x minus 2. And then I have to take the opposite of there, which is negative 8. And I have to flip that sign because I just made it a negative. Okay, add 2 to both sides. I get 3x is greater than or equal to 10. Divide both sides by 3. And I get x is greater than 10 thirds, or 3 1/3, or 3.333. I do. Yeah. Or, solve the other side. Add 2, add 2. These cancel to 0, or add up to 0. I get 3x is less than or equal to negative 6. Divide by 3. Divide by 3. So x less than or equal to negative 2. What's my smaller number? Negative 2. Negative is always smaller than positive. So negative 2 and 10 thirds. Okay, negative 2. This is an or problem. So they're going to go out, right? I heard bracket at negative 2 because of the equal sign. They're going to go out to negative infinity. And then I'm going to have bracket or parenthesis at 10 thirds. And that's going to go out to positive infinity. So my interval, negative infinity to negative 2, bracket, union, bracket, 10 thirds, positive infinity, and infinities always get the parentheses. All right, let's do A. My absolute value symbol term is already isolated. So I'm going to take what's inside, keep everything that's there. What kind of problem do I have? Or 4x plus 10. I'm going to take the opposite of what's there, and when I do that, I have to flip the sign. Okay, subtract 10, subtract 10. These add up to 0. I get 4x is greater than 2 minus 10 is negative 8. Divide both sides by 4. So I get x is greater than negative 2. Or what? It's greater than. Okay, it's a greater than problem, which means it's going to be an or. Okay? All right, so same thing with the other side. I'm going to subtract 10. These add up to 0. I get 4x is less than negative 12. Divide both sides by 4. And I get x is going to be less than negative 3. Now it's an or problem, so they're going to go opposite ways. Which one's smaller, negative 2 or negative 3? Good. So we're going to go opposite ways. Do I have, at negative 3, do I have parenthesis or a bracket? Good. Going to go out to negative infinity. 2, parenthesis, no equal sign. That's going to go to positive infinity. The interval then, negative infinity, comma, negative 3, parenthesis. Infinities always get parentheses. It's an or problem, union, negative 2 with the parenthesis, positive infinity with the parenthesis. Okay, B, they're giving you a little bit of a hint. You know, they're putting asterisks there. So what do you think about when you see asterisks in a problem? Yeah, something's going on, something special with this, right? Before we do all the work, and I tell you what's special about it, does anybody care to take a gander at it? No solution? No solution. Okay, are you saying that just because you see a negative number there and with equality, there was no solution? I'll do it the long way if you don't think about this. Somebody came up with the right answer. I can't. Well, we're going to have to do it then. All right, so 2x plus 3 is greater than or equal to what's there, which is negative 4. It's an or statement, right? It's greater than 2x plus 3. I have to flip it and take the opposite of what's there, so that's 4. Okay. I'm going to have to solve each one of these. Minus 3, minus 3. So I get 2x is greater than or equal to negative 7. Divide by 2. Divide by 2. So I get x is greater than or equal to negative 7 halves. or subtract 3, subtract 3. So I get 2x is less than or equal to 1, divide by 2, divide by 2. I get x is less than or equal to 1/2. Okay, which one is smaller? -7/2 and 1/2. Okay, this is an OR problem, so they're going to go opposite ways, right? Is this going opposite ways? Yes. Okay, let's do this. -7/2. I want all of those numbers greater than or equal to. So I got a bracket, but I want all of them greater than. Okay? So I want all of them greater than. So this is going out to positive infinity, right? Okay. I want at 1/2, I want a bracket because I want to include 1/2, but I want all of those numbers less than 1/2. So they're actually overlapping. They're still going opposite ways, kind of, but they're going opposite ways overlapping. So what numbers are going to work here? All of them. All of the numbers are shaded, right? So it's going to go from negative infinity, positive infinity. That's the way we write all real numbers in mathematics, in interval notation. So we could have saved a lot of work if we would have just went back here and thought about this for a minute. Remember what I said about the definition of absolute value, right? Everything that comes out of there is positive. This is not an equal sign. This is a greater than sign. Let me ask you this. Are all positive numbers greater than or equal to -4? Any number that's put in for x, will it be, and I take the absolute value for it, will it be greater than or equal to a negative number? So we've got two rules here. If I have an equal sign, an absolute value, equal a negative number, we have no solution, right? If I have an absolute value statement that's greater than or equal to a negative number, it's going to be all reals. What do you think less than is going to be? No solution, because it will never be less than a negative number. If my absolute value is less than or equal to a negative number, there's going to be no solution again. Okay? If you want, you can try the problem.